Hi people, this is tutorial number 13 in the playlist which deals with meshing in the 3D Experiences FEA solver. Uh, Now, it is to some extent related to tutorials 11 and 12, but it can also be done independently. So the problem that we're doing is, let's look at a cylindrical vessel. One end of it is capped and the other end of it is open. And the only reason I make both ends open is basically I want you to be able to see what's going on inside of that. Suppose we measure in the form that you see, and we apply a pressure of 0.1 megapascal as shown here. The question is, will it bulge out? Will this cylinder bulge out or bulge in? In all likelihood, most of us are going to say it bulges out. Okay, so the answer is no. That's because you'll see in a second is that you need more information. So it's the same dialog box, it's the same cylinder shown like that. One end is clamped, one circular edge is clamped on the other side, and internally it's pressurized. Well, it's pressurized in that form. At least that's what 3D Experience shows up. The problem is that this actually will bulge in. So the reason that this can be confusing and not enough information was provided to you initially was that you have to know where the positive surface, which means top surface, and negative surface of the shell elements are. Okay. Ultimately, this is what I did in tutorials 11 and 12. Okay. Identifying what are the positive and negative faces of a shell element. We will get there, but let me move on and show you the rest of the slides, and I'll do as I do the examples. We'll come back and get to this point later on. Okay, I'm going to create this geometry for you. The dimensions are given on the first slide, and I'll load it like this. Notice that there is a distinction between this diagram. The outside here is magenta. Magenta is the positive side, and here the outside is blue. That is the negative side or the bottom surface. So although they look the same, but this information will make a difference. I will show you that if you apply the same information in the dialog box to this uh, top configuration, it actually bulges out as you expect. So without knowing this, without knowing where the positive and negative surfaces are, you won't be able to tell me whether it's going to get fatter or it's going to get slimmer. Okay? And I'm going to do that for you. So this is the figure that I showed you initially. Okay? I showed you initially that, you see for a second, is this the one that I showed you? Yeah, this is the one that I showed you initially. So notice that here, the pressure is the way it's drawn is applied on the, you see this arrow? This arrow means that when you apply this pressure, you apply that to the top side or positive side or magenta. And if you're applying pressure to magenta, is pushing in with this is a positive number, pushing into the magenta, it's going to become slimmer. Okay, that's why we could not answer the question initially. So let's go ahead and do this problem. I'm going to create that cylinder in generative shape design because I need to create mesh elements. Therefore, we need surfaces. So let me draw a circle here and dimension this thing to be radius of 40, 40 millimeter. Actually, I'm not sure. Let me see for a second. What do they have here? Radius of 40, length of 50. Okay. So let's see if it looks right. Okay, good. Exit. exit this. And then we extrude it by create a surface, extruding it by 50 millimeters. And there's a surface. Okay, does that look like this, by the way? It's okay. Yeah, that's fine. Let's apply material to this. We'll make it out of steel, standard properties, because we're going to do linear static analysis. This has nothing to do with this static or dynamic or linear or nonlinear, etc. But because we're looking at the issue of the positive and negative surfaces, we can take the simplest situation. So tools, let's create one, and this is steel cylinder, January 6, 2024. We say okay. And once it pops up in the list here, I'm going to select it and apply it to my part. So I'm going to apply. We don't need this stuff. We can close it. I'm going to apply to this and put in the values. So let's go to the material. It's structural, abacus multiphysics, mechanical, elasticity, elastic 200 gigapascal or 200,000 MPa, 200 GPa, and Poisson ratio 0.3. Okay, good. All right, so these planes I don't need, so I'm going to hide them. And that sketch also I don't need, I'll hide it. Okay, so you can see that my, all right. I just noticed that in this drawing, it looks like there the radius, it looks like the radius was actually 20, not the diameter. Not 40. Okay, so let's go back here. Let me go change this thing. So we go back to that sketch. That radius, I'm going to make it 20 because I think that I want to be consistent with that drawing that I have. And I think over there, let's check. Yeah, I think that's more consistent with the drawing that we had before. Really, that's not the point, but okay. Now we're going to go mesh this thing. So let's go ahead to uh, the robot on the top left corner and click on the structural model creation. That's where the meshing takes place. Empty FEM and mesh, right? This is the meshing tab. Here is the surface measure, quad surface measure. You select that and 5 millimeter size, linear, you can see that. And we say mesh, and it's going to give you the mesh that you saw in the other slide. We close that. Now, as soon as you mesh, then you can plot the positive and negative sides of the shell elements, or top and the bottom sides of the shell element, or magenta or blue sides of the shell element. So, and the way you do that, you go to this right here, mesh, under display, see that? There is this guy, and this gives you basically the visualization of the mesh of the elements. This is the standard one, where direction is not, or positive, or sense of the side is not specified. But if you go to the third one, it shows it to you. And if I hide the extrude, you can see what happened. So inside is the positive side, outside is the negative side. Inside can be viewed as the top of the shell element. The blue can be viewed as the bottom of the shell element. So that's what, we go back to this slide here. This is a situation, okay? All right, so let me actually hide the mesh, but show the surface. There we are. Because you want to clamp that end of it. First of all, uh, let me apply material properties to this thing. So we go to properties, shell section, select that extrude, and thickness of I don't know, 5 millimeters, 5 millimeter thickness. Say okay, good. So we have properties here, and now we're going to go to structure model creation. We use the mesh that I just created. We're going to have to define a step. You've got two ways to do this. Because we're doing linear static analysis, one option is to select a static step and then uncheck the geometric effect, non-linearity effect. That's one way. The other way is to do a static perturbation. Static perturbation, or where everything is linear, is essentially the same thing. So in to be consistent with what I've done in tutorials 11 and 12, I'll go and do static step. Static step. Under advanced, to uncheck the include geometric nonlinearity. As soon as you do that and you have linear material properties, essentially it becomes it's the same as doing a static perturbation. But my mesh, good. So we go under the boundary condition. We fix that other side. So there it is. Fixed displacement, which means clamping it in a sense. All 6 degrees of freedom are fixed. All right. And then we apply pressure. Pressure. Now be careful here because I'm going to select this extrude, but what it does, it puts it on the top face. You see that? This means this means that it is putting it on the magenta face. Magenta is inside, right? Magenta was inside. And if magenta is inside and this value is positive, 0.1 is, of course, it's going to push on the magenta, making this thing expand. All right. Uh, Remember, positive number on the positive side, positive number on the magenta. Magenta is inside. It's going to push it out. Okay. So we say okay. And now pretty much it. We're going to run it. So let's go ahead and uh, under simulate, let's go ahead, and I'm not going to bother checking the model or the simulation check. I'm just going to run it because it's a simple problem. I know what's going to happen. This is going to bulge out. That drawing suggests to you, but as I will show you in a minute, that drawing can be misleading because if I flip the directions, put the magenta outside, same drawing will actually make it slimmer or contract. Okay, so this is going to bulge out. Okay, close that, bulges up. You can see that, bulged up. Now, what I'm going to do is I'm going to go to the mesh right there and flip these direction. And that's all explained in tutorial 11. So what we do is under the meshing, we are in meshing. There is an icon called meshing editor. You click on it, select the 2D mesh. Oh, this is a 2D mesh. Notice that the menu changed down here, and one of the item down here is flip elements. So if I say flip all, what happens? It puts the magenta outside and blue inside. There we are. And we say, notice that I did not change anything as far. And make sure, by the way, you exit this app. Make sure you exit the app properly. And now we go back to scenario. Notice that I did not change the pressure. If you double click on the pressure icon, if you double click on the pressure icon, notice that it is still on the top side. Now top side is outside now, and a positive value. So a positive value on the top, on the magenta side is going to push into the magenta and make this thing contract. Okay, so that drawing did not change. The only thing that changed is the outside and inside uh, colors. And now we're going to go run it. And when we run that, you're gonna see actually it contracts. It becomes slimmer. Okay, close that. There we are. Became slimmer. There's one more thing I want to show you, and that is, let me remind you how you can display, beside the color, you can also display the coordinate system for the mesh. So what you do is you go under the plot, you're under the plot, go and find the icon which says a symbol plot, and among the in the third in the first tab for template, under the variable, you select orientation, and then we say apply. Notice that magenta was outside, positive side was outside, and therefore the positive normal to the element is pointing out. In the first case, these arrows, these blue arrows would have pointed inside. But anyway, that is after we fixed it, after we changed it, not fixed it. So you have to, no, in many situations, people just go ahead and do it. If it doesn't look right, they change the direction, or put a negative number for the pressure, and it may work, but it will work, except that here's why. This is the reason why it is working. Good luck.